Imagine you're in legal. It's 7 p.m., your client calls you and asks you to pull every single agreement for this specific company with this certain clause, final drafts only, and they have to be signed. Now if you're organized, you probably know exactly where this folder is with all the agreements in them. Then you gotta go through and check all of them to make sure they all have this specific clause that your client's asking for, and that they're final draft, and that they're signed. Now imagine you're in HR and you get a question from an employee about parental leave. Now this employee might have just moved from Ontario to Alberta, and they're wondering how many weeks are paid versus unpaid, do their benefits continue, is there a probation period, and what's the notice and where can they find the forms. Now first you have to open the company handbook to find the basics. What counts as a part-time employee versus a full-time employee? Is there any probation period? Do benefits continue? Is there any notes for employees living in different provinces? Next, you have to open the union agreement because you find out this employee's in the union, and this handbook takes precedence over the other one, so if anything in this one is different from the company handbook, then you follow this one instead. And then finally, you have to grab the benefits in the process, if healthcare and dental continues, who pays, what's the probation period, and then you have to find the links to each of the forms, and then you have to send it to the employee. Thank God I'm not in HR. Now those quick questions can eat up hours, sometimes even days of your time. And RAG solves this. Now what even is RAG? RAG stands for Retrieval-Augmented Generation. It's pretty much AI but with a library card. Now it has access to your documents, your data, and can use that to generate responses based on it. Now with traditional models like ChatGPT, you can ask it questions, but it can only give you answers based on what data it was trained on. So you can ask it questions like, how long do cats live? But you won't be able to ask it questions like, what are the top 3 customer complaints mentioned in our support tickets last quarter? Or list all API endpoints mentioned in our developer documentation that handle user authentication. Or show me all contracts that are expiring in the next 60 days based on our contract database. RAG also provides you with transparency. When RAG generates a response using your data, it also generates a list of documents that it used to generate its response. It also gives you a list with links to each of those documents so that you can go and verify. Now, RAG stays up to date with your company's documents. You simply have to update your document corpus or database, and RAG will automatically have access to that new information. Now, here's a RAG system that I set up, and I'm going to demo for you guys here today. So one thing you should know about this system is that everything is run locally. So all the models that you see and have access to here are run on a local machine. Now this machine has 6 3060s, a 3070, and a 3090. Now this adds up to about 104 gigabytes of VRAM. Now I'll outline the architecture for you guys here. So this is all running on a Linux server, once again locally. Now the first 4 GPUs are hosting Gemma 12B. So this is the main model we're using for our response generation, mainly because of its reasoning capabilities. So this is a 12 billion parameter model by Google. Excellent for reasoning, excellent for content generation, not as speedy as the other models. Now on GPU 4 and GPU 6, we're running Gemma 2B. So this is another language model created by Google. This is a smaller model. This is considered a small language model actually. It's only 2 billion parameters, but it is super speedy. So this is great for short form summarization, classification, stuff like that. Now on GPU number 5, our 3090, we are running Phi-3.5 Mini. So this is another small language model, but this one's by Microsoft. So another super speedy model. Once again, great for classification, great for summarization, even content generation. This has substantially better reasoning capabilities compared to Gemma 2B, in my opinion. We're actually using this for classification in our RAG pipeline, which is something we'll dive into a little bit later. Now on our last GPU number 7, our last 3060, we are running LLaMA 8 billion parameters. So this is a model by Facebook, great model, excellent reasoning capabilities considering its size. It is great for longer form summarization, has a pretty large context window, 128,000 tokens. We're not running with the full 128,000 tokens on here, but it does scale to that. This is great for question answering as well, so you can upload your documents, ask questions about it directly in our chat interface. So here's a quick demo of the RAG-enabled response. So the way that I built out this front end here is you can choose between 4 different models, but when you select document search or RAG-enabled responses, it will default automatically to Google Gemma 12b. Now the reason for this is because of its reasoning capabilities and also its context window. So this company gave me documents like policies, procedures, technical documentation, documentation on some of the projects that they're working on, PowerPoints, so what the company's about, so stuff like that. So I'm not going to ask anything too crazy here for sake of privacy, but we'll ask a simple question like, so TTG, so this is the name of the company. So right now it's analyzing the question. So this is a real-time process streaming. So when you saw the analyzing question, what it was doing was it was retrieving the context required to answer the question, or all of the context it could find that can be used to answer the question, and then re-ranking them based on relevance, and then sending it over to our LLM for response, in this case Gemma 12b. So now as you can see here, it's generating a response. So response generation, considering we're doing this all on local hardware and there's, we have constraints, it's not going to be crazy fast. So as you can see, it took 38.03 seconds to generate that response. But as you can see here, this is generated directly from the documents in the database. So these are some of the projects that they're working on, really cool projects this company is working on. And if you go here, you'll see a drop down of the sources used, and this is a list of all the documents used to actually answer the question. And then if you click view document here, once again for company privacy, I am not going to click this because it'll take you directly to the Google Drive where you can view the exact document and verify some of the response generated from the LLM here. So I've showed you guys the AI infrastructure setup. Now I'm going to show you exactly how the retrieval and response mechanisms work in our pipeline on our Linux server. So we have a fast API server running on our Linux machine here. So this is the same machine that has all of our GPUs that we're using for model inference. So let's send a request here. RAG enabled, of course. When should I be using emails? When should I be using emails? Once again, nothing too crazy here. So we have analyzing question. So let me show you exactly what is going on here. So as you can see, here's our query. So this is the model that it defaults to, Gemma 12b. RAG mode is enabled. So what it's doing here is it is using semantic search to query our vector database and find any documents that can be used to answer the question. Now what it's also doing is it's using keyword search. So semantic search is more of a broad search. Keyword is more precise, so it's going to look for, or it's going to find documents that our semantic search might have missed, searching for relevant documents. So what it's doing here is it's grabbing the top 5. So with this, we are using a hierarchical search approach. So we've generated summaries for each of the documents in the corpus and then embedded those and added them to our vector database. So when a query comes in, first it checks the summaries, and then from the summaries it goes to the documents. So this is just a way to better pinpoint the exact document that can be used to actually answer the user's query. So from there, it is grabbing chunks. So think of chunks as pieces of a document. So when when documents are added to our vector database, they're not added, like we don't add the full document. First, we chunk it up into little pieces. So in this case, we used 512 character chunks. So we started at the top of each document, we grabbed 512 characters, and then we grabbed another 512, and then another 512, until we get to the end of each document. Then we add those to our vector database. So when we're querying our database, we are looking for the exact piece of the document that can be used to answer the question, as opposed to grabbing the full document. Now, this is just a lot more efficient and a lot more precise way of finding answers to questions. So from there, we are grabbing only the top chunks. So we're merging the top chunks from our semantic retrieval and our keyword retrieval into a single list. So if any documents show up in both lists, they get pushed closer to the top. Now from there, we are using a context judge. So we are using Phi-3.5 Mini, the model created by Microsoft. So this is a small language model, about 3.8 billion parameters. The main reason we're using it is for speed, and it showed best reasoning capabilities out of all of the small language models we tested. So what we're doing here is we're passing each of those chunks, each of those little pieces of the document that we just retrieved. We are passing that to our model with a specially crafted prompt, instructing it to classify the chunk as either relevant or irrelevant based on the user's query. So this is just an extra filter to help remove chunks that can't be used to answer the question. So as you can see here, here's how our model is classifying each of these chunks. So chunk 2 of 21 was not relevant. And you can see a list of all of its decisions here. So from there, we take only the chunks that are classified as relevant, and we feed it into our main response model, Gemma 12B, with a specially crafted prompt instructing it to answer the user's query with only the given context. And then from there, our response is retrieved, and we add our links to each of the documents, or our list of documents used to actually answer the question, and then it is presented in our front end so the user can see it. So as you can see here is the answer to our question. You can click here and you can see the sources used, and then the link directly to the document used to answer the question. If you enjoyed the video and you'd like to stay up to date with anything data science, artificial intelligence, or machine learning, make sure you hit the subscribe button. Thanks for watching.